My name is Louis Ancajas from Micron, and Micron is a large flash memory semiconductor company, one of the world's largest, and we're here to talk about cybersecurity, which would be probably challenging to think about at first, but after we talk about the Authenta Cloud Platform, I hope we get there. This is something that you can imagine if you had a foundation that is really strong, really pervasive, you can actually scale cybersecurity across the many things that have to be secured. And that's what the Authenta Cloud is about, and I'll bring you up to speed more on that during the course of this talk. But just as a tagline, okay, Authenta is bringing connected services, connected products to the cloud, to life, faster, more easily, and more secure than ever. And I will elaborate on that because I know this audience here really wants to hear about what am I talking about. Okay, so I'll go and skip a little bit more to the answer, or maybe the thesis, and then we'll come back to the market drivers, okay? But what you see on this chart is that there's a journey to go from a secure device to a deployed service. And there's just a disparate, connectivity between them. And then when each of the stations, there's also a lot of complexity. So pulling that all together has been something not easy to scale. What has happened in the industry is there are silos that people create, and that's to do it yourself. So Apple's a silo, Google's a silo, they build a system, they take care of it in their manufacturing floor, they're designers, they design it very specifically, and they coordinate this with their cloud people, okay? So that is something you can silo. But if you want to do a massive, and the way the world is going, scaling this thing across all kinds of systems from your watch to your surveillance cameras to your even your PCs, there's just a lot of coordinating that has to happen. If I go down the list here, just to give you guys a little bit more detail, from the left is a set of SoCs, a lot of different microprocessors, a lot of different security architectures. And so you have to get the right embedded, as you guys are all network experts here, you have to get crypto experts, embedded architecture experts who know how to put secure systems, secure silicon together with the firmware, with the silicon, and then during the execution, there are these siloed execution that you can create. That's one discipline. Transferring that over, once you secure your system, you've actually kind of bolted down it's secure, but the other problem is it's rigid. I made it rigid, so now when I move it on, and I want to have the owner do something extra to it, I want to have the customer maybe personalize it with something, that has to have been pre-rigged. Right? So it's not a flexible thing. So you have very limited ways of updating your product after you have secured it. And that's a challenge. You then have to go from party to party to party. Sometimes we're talking about manufacturing where you're going from a contract manufacturer to a subcontractor manufacturer to eventually a deployment. In the government, we have many different things. We have subcons, we have subprimes, and then we have primes, and then we actually have to also provision something when they go to different states, different nation states. Ownership transfer is a kind of a challenge in security. I want to give ownership, but I also want to keep it secure. So you have to make sure that happens really well. And then deploying certificates. Certificates have to stand behind the security. The certificate guys are way out there, closer to the cloud, and they haven't been involved in the manufacturing. So I'm giving you a good kind of, hopefully, image of the problems that the system OEM faces to coordinate with the cloud. And eventually, one last step is when you have the cloud, they have their own APIs, they have their own ways of talking to the devices, and they don't want to have to care about what the device is, right? So if I am a data center and I want to manage every single one of my servers on the system, there's an AMD version, there's an Intel version, there's a 3-year ago version, and there's a now version. And there's all kinds of complexities if you have to keep disturbing the way the APIs work with the hardware just because of the different nuances of the hardware, okay? So that's the story. We're gonna make this really simple in a way. And so there's one novel thing here. It's just the addition of all of these different nuances and complexities along a chain, along different parties that make this literally very impossible unless you are, again, the big guys who do it yourself, okay? So what is driving the industry to solve this problem? There are a lot of markets, and these are examples of where Micron is working with notable, established leadership companies. In the mobility space, the car is transforming. The auto industry is completely transforming. You're not going to have to buy a car. You're going to be able to get an app and pick up a car in the parking lot and drive it. And you, as an owner of a car, may be able to rent your car for an hour or two and be able to make some money while you're sitting in your office and somebody else driving your car. One example that's out there, and it's a growing market, but even within your car, it's going to have personalities. If it gets sold to Hertz, there's going to be all kinds of services and things that are rendered in the car. If it's bought by somebody who wants to have different luxuries, you're going to be able to turn on the luxuries. They're going to sell one car, but you can turn on luxuries. There was an announcement about BMW selling heated seat service. Okay. Nice thing about heated seat service is you don't have to make that decision when you're at the dealer and pay an extra 15 grand just for the luxury model. You can be at the mountains and you can have your children crying, being desperate, then your mother's just going to say, okay, darn it, let's just pay $20 because my children are cold. That decision process is easier. It's a lot more profitable, especially when you sum it up, okay? A lot more profitable than when you buy things at the dealer. So if you push all of these things out to the consumer and make purchases there, this economy is going to be much better. This is called the digital economy, okay? Digital transformation, there's many words for it. So Micron is doing this a lot with automotive. There's tons and tons of automotive modules that need to have the control and the updates to allow those things to happen. Industrial automation is actually a very classic example. When you're pushing things out to the edge and controlling devices at the edge, you have artificial intelligence data that you want to keep adding in there. You want to continue to authenticate and monitor the data that's out there in the cloud. So you need security there. And believe it or not, the data center was the thing that blew me the most. That you would imagine in a controlled environment of a data center, it's locked down. You got to have guns and guards to get in. You have to get through those. There is security in every server because they want to optimize the operations of a server. So the server is an IoT. The server has to be controlled, monitored remotely, provisioned. And actually, they're able to sell servers at an hour. So they call that bare metal as a service. And that's another driver for a server to look like a classic IoT and become subjected to all these attacks by being remotely controlled and remotely managing. These things are driving why we need cybersecurity. They create operations, they create new efficiencies in the way we work, okay? But this is the biggest reason why this is important. And then I'm going to let my architects talk about what this is for you guys. The economy has to shift. We aren't selling systems anymore and getting money off of that and then saying, okay, good. My marketing director likes to talk about a pet rock. If you have a pet rock business, you're trying to sell as many pet rocks as you can. Get it across 6 billion people in the world, and you've maximized the market and help them own 2 pet rocks, right? But if you had a pet rock that was dynamic and it could do all kinds of things for you, it teach you a language, it could teach you how to cook and give you recipes. It offered you something that gave you a closer relationship and make money out of that. Now you have the cost of the rock plus an infinite amount of services attached to it. And that's what all the companies want to do today. They don't want to sell a phone. Apple, if you look at them up, you're going to see how rich they are in terms of their services. You don't want to just sell a laptop. So the Dells and the HPs of the world are striving to figure out this problem, and so forth. So that, I think, is the biggest driver of cybersecurity. We are messaging cybersecurity this way. You're not going to hear the classic, do it, or else you're going to get broken and your reputation and your fame is going to be all lost. This is about opportunity. There's a big opportunity if we can seal the world with secure, trusted devices and allow consumers or buyers to have the services that you can render from it. There's a big cost to this at the system level. You have to figure out the development and the operations. As I mentioned, that itself is a challenge. You have a low-level firmware, silicon engineer, and you have a cloud API, people that know Python. One knows C, one knows Python, and then all of this stuff in the middle, right? Coordinating that. But then when you start to add security on top of that, you got this whole exchange even more tightly binded together, more interdependencies. So that slows down, that costs more, and you're not achieving the fundamental thing of getting the system out there, and trying to get to market, get revenue. When you then design it and you now figure out how to deploy it, you have to build it. And when you build it, you're going to go from a factory, maybe in Taiwan or US, building the silicon, and then you ship it to some contract manufacturer, and they're going to load it down. Regardless of how you design it, there could be a rogue person in the floor who will introduce something malicious in there, or take something out, or copy it. You know, there's all kinds of stuff. Even after we've done the DevOps and we have securely figured it out, we still need to now practically carry out the manufacturing process. Finally, when you get to the field, of course, now you're in the field, everything's game. There's all kinds of attacks and threats, you know, and you need to have the proper security. So there's this whole thing that has to manage during the life cycle of the system, okay? And that's why we built Authenta. Now, Authenta, I've described the problem. I described a little bit of the different areas. It's a three-laddered thing. It's a three-pillar thing where we have a silicon that's going to have a standard silicon security base with identities and with cryptographic keys for control. There's going to be a tool that knows how to talk to Flash language and a tool that knows how to talk to API language. So the people now who are going to be involved in using Authenta don't have to be one or the other. They could be what is today the classic system architect, network architect that can understand how this works enough and be able to control it and provision it the way they want it to work. And then there's a cloud that's needed for the delivery of things across the ecosystem. So our cloud has the ability to send keys, credentials, do platform identities services, so that it helps in the facilitation of all of these systems going out into the field. Okay, so we think that it's going to have tremendous value if you look at the way we aligned all these three things together. Total cost of ownership is not going to be as much. The ease of use is going to be simple. And then you're going to have confidence, because the one other thing that's really key is that when we did it in the silicon, we did it in the flash, we're protecting the entity in the silicon with an agent in the silicon, all in the same security perimeter. You know, so there is now a smaller surface threat surface. So this security architecture makes a lot of sense to put root of trust, security protection services on the silicon. That's why we built Authenta. That's why Micron's doing the silicon, but Micron had to figure out the other tiers to make this thing proliferate and be easy.